Welcome everyone to building a decentralized application using the Portis API. My name is Pavel and I'll be your host for this evening. This workshop is for people who have heard of Ethereum, who want to explore aspects of Ethereum development and have a bit of programming experience. So this is mainly focused for developers. My name is Pavel. I'm a software engineer by profession. I've authored blockchain development videos and tutorials, and I've also created and led the CryptoChicks Hatchery blockchain program, which helps educate entrepreneurs looking to start a decentralized business. I also enjoy teaching blockchain development topics worldwide. There's my headshot. As you previously saw, I did have a beard, so I need to update my LinkedIn for that. So today we'll be going over the coding aspect. A lot of presentations talk about the why, the architecture, and the what, and the how, the smart contract. I will be talking about the what, the actual code. Hopefully, this will be able to give you an additional perspective on the implementation details of smart contracts and how it all works together. I'll be going over deploying a partial ERC20 token contract, and I'll also share some resources for smart contract development. So this will be a live development workshop. So there are some cons to a live development workshop. Things can go wrong. Now that's a pretty big con, don't get me wrong, but a pro to a live development workshop is that things can go wrong. Essentially, anything that goes wrong, it'll give you that extra perspective on how a developer comes and the developer mindset solves these types of problems. And hopefully we can get everything to work. Now, let's get building. Elena has shared some resources for the actual workshop today. So first and foremost, the actual GitHub page where you'll find the development resources and also a step-by-step walkthrough of today. There are a couple of links here that if you're following along either right now or in the future, I want you to open. So first and foremost is the Portis wallet. We are using the Portis API, so we will be using the Portis wallet as well. Next is the Code Sandbox. Now this is a link to the test Dapp, which is the application that we will be connecting to our smart contract that we will be deploying. We also need to open up the Remix IDE, which is a smart contract development integrated development environment. And I'll be going over more details about that. And finally, we want to open up the Ganache faucet that I've set up prior to this, this workshop. So the Ganache faucet is here. You're able to get test Ethereum in order to fuel your transactions that you'll be deploying. And I'll go over that a bit later. All right. So now that everyone has all of those resources open, I'll first like to start by going to the Remix Ethereum IDE. Now we want to implement a token contract, an ERC20 token. What an ERC20 token is essentially a monetary token. You're able to transfer a set amount to a specific address. We'll be implementing that now, and you can see through this implementation how this works. To start, we want to click the file icon in the Remix IDE editor. So to create new file. Then we want to type in token.sol. This creates a new file within the Remix IDE. Don't worry about the additional folders such as contracts, scripts, tests. We're not going to be using that. We just want to create the token.sol. These are scripts to just get you started on your first smart contract, but this development will teach you how to build a singular smart contract with the token. Now, navigating back to the GitHub page, we're able to scroll up and see that there is a file named token.sol. If we click on that file, we're able to see the code that's involved with an partial ERC20 token. Now, if we go ahead and copy this code, then if we navigate back to the Remix IDE editor and paste the code, there it is, and save the file. It throws a bit of an error, but we'll discuss that. First and foremost, I want to point to the Pragma Solidity 0.8.0. This defines the actual version of Solidity that we will be using. This is very important as different contracts that are deployed onto the Ethereum network use different versions of Solidity or compile to different versions of Solidity. And it's important to always specify the version. Next is that we have the actual name of the contract token. Now, if people are familiar with object-oriented programming, this is the same exact, this is a class, essentially, in object-oriented programming. So the contract, imagine if this was class token. So instead it's contract. We want to specify that it's in contract, we're creating an object. Next is that we have a mapping of all of the balances. So what this is that we specify a balance, and then in square brackets, we can specify an address, and that address will translate into a uint 256. So essentially an integer, which is the balance of that address. Next is that we have a couple of variables. So first is the total supply. That's how much of our ERC20 token that we have currently in circulation. Next is we have the name, which is the name of our token. We then have the symbol, which is the symbol of our token. And we have the amount of decimals that our token will have. So typically, I think by standard, it's around 18 decimals. But you don't need to worry about that. Essentially, it's just a partial token implementation. So don't worry. Then moving on, we have our constructor. Now, as soon as we deploy our contract, this is what is required in order to successfully deploy our contract to the Ethereum network. So we need to specify a name, a symbol, and an originator. And essentially, we're specifying the name of the token, the symbol of the token, and who gets the tokens that we create when we initialize the smart contract. So in this case, we want the originator to be us. And this sets the values to the corresponding values in storage. Next is that we have function name. So this returns the name. Function symbol, it returns the symbol. The balance of, it takes the balance and in square brackets the account, which then returns the balance of that account. Next is the transfer. Now there's this require function, very important. This essentially is saying that we require something to happen before the rest of this function can be run. We require the balances of the sender of the transaction to be greater than or equal to the amount that they want to send. Essentially, they cannot send more than they specify. So if they only have 50 tokens, they can't send 60 tokens. So we want to make sure to output an error message saying that you do not have enough tokens to send. Next is that we have the balances. So we want to decrement the balance of the sender by the amount that we're sending and increment the balance of the recipient, so who we are sending it to, by the amount. So this process sends the token, or sends the tokens. Finally, we have our private function. Now this function, mint, very important. Otherwise, we wouldn't be able to have tokens to send to begin with. Now with our mint function, we specify an address, which in this case would be us, and we specify an amount that we want to generate. This increases the total supply and increases the balance of the account that we are sending. Note that this function is private, while the rest are public. What this means, private, essentially means that it's restricting who can call this function. We want to restrict who can call, for example, mint, because we don't want anybody to create the tokens. We only want us to initially, when we initialize the contract, to create the tokens. We don't want to let anyone else generate 1 million tokens just out of nowhere. Otherwise, our tokens would be worthless. Now that we know exactly what the smart contract does, let's actually compile it. So as you can see, we have an error saying that it's a different compiler version. We want to set it to our version of 0.8.0. This takes a little bit of time as the Remix IDE is trying to actually get and download the compiler version. As soon as we see, as soon as we see a solid color, we can click compile token.sol. So this compiles our token. And in this case, it also generates an ABI and the bytecode of the token. The ABI is the application binary interface. This allows us to communicate with the contract. It specifies the parameters, the inputs, the outputs, the data types, essentially all of these functions it specifies, so that we, when we interact with it in our test Dapp, we can specify which functions we would like to call, and we'll see that a bit later. So we have the ABI here and the bytecode. Now we'll hold up on copying it because we still need to deploy our contract.